So what we're going to do now is the main focus of the rest of the unit, which is transforming sine and cosine graphs. So remember, when we get parent functions, we have a certain pattern, but to fit it to word problems, which is where we're going with this, we want to change different things with transformations to make it really fit in with the information for our problem. So we're going to do a tiny bit of word problems today, mostly just working on transformations, but that is ultimately where we're going. So the three things we're going to look at first are the three qualities we talk about of a trig graph, which is their midline, their amplitude, and their period. So as a review, the midline is that horizontal axis, the horizontal line that's in between the max and min. The amplitude is the height from the middle to the top, and the period is how long it takes the graph to repeat its pattern. So we're going to look at some graphs and just decide what these would be. We're also going to find the max and min value, which is something we do with lots of different types of graphs. So looking at my first one, the highest y value is a 3 and the lowest y value is a -3. The midline is directly in between them, so we can see this one pretty easily visually. That's y equals 0. And the amplitude is a 3. If I trace out this graph, usually I start on the y-axis. I'm going to trace it out until I get to the point where if I moved my pen further, I would start repeating what I'd already done. So from here to here is the period, that's 0 to pi, so the period is pi. Looking at the next graph, we happen to have it in degrees, which is not typical, but just in case you see one like that. And at any point you can go ahead and try these, because this is something in class I'd probably have them just do on their own and then we check them. So the highest value here is a 9, the lowest is a -1. The midline, you can see it here, but if I wasn't sure where it was or I didn't see a picture, I would add those two together and average them. Right? So we're averaging them to see what's in the middle. So I get 8 divided by 2 is 4, and if I look at where I drew that line, it is at y equals 4. Amplitude here. So I'm going from 4 up to 9, or we could do a 9 minus 4, right? Or we could just look at it as a 5. And the period here, if I start on the y-axis, this looks more like a sine pattern. This is the spot where I'd start going again, so the period here is 180 degrees. So we have 2 more graphs on here that we're going to look at. So looking at these values, highest, lowest, -1. is the highest, and the lowest is -3. That means my midline is right between them, y equals -2. The amplitude is just a 1, and the amplitude is always positive. Okay, so it's just a measure of height, so it's always positive. And the period, to finish off this graph, looks like it's about 2 pi. My next one, 3 and -3 again, so my midline is 0, and my amplitude is 3. The period, this one takes a little longer to finish. So here, and then if I went again, even though I can't see it, I would start again, so the period is 4 pi. So on the next page, we're going to look at more of like what you might see in a word problem with this type of stuff. So it says weekly temperatures were recorded in a graph to the right. So this is a scatter plot, but we see that it follows a trigonometric pattern, like a sine or cosine graph. And these questions are really hidden of what we just did on the last page. So the median temperature, which is like kind of like the middle temperature, is just my midline. So if I drew this in here, it looks like my midline is about at 40. So I could write 40 degrees Fahrenheit. The highest temperature, and I'm estimating, looks like it's about 70. And the lowest temperature looks about like 10. So the difference between the median and the high is 30, right? 70 minus 40 is 30. And really, this could be thought of as an amplitude question. Right? This is really a midline question. And then it says the number of weeks it takes to repeat the cycle of temperature. So this is really a period question. So we follow the graph. We see it's about right here. Maybe I think it's 50, but because I have some knowledge of the year, I'm going to say 52 weeks because that's how long it is for you. So that's just starting to look at how we do our word problem. That would be a little bit more math to do in there, but that's the idea. And temperature over the year does follow the temperature pattern. So now we're going to start to connect transformations to these trig graphs. So we were more just looking at midline, amplitude, period, those new words, but each of those is connected to some sort of transformation. So right here I have a graph of sine, which is what we learned in the last lesson. So we have 5 different groups of transformations: our reflections, vertical shifts, horizontal shifts, vertical stretches and compressions, and horizontal stretches and compressions. And we want to pick one of those 5 that will affect each thing. So if I want to move the midline of the graph, so let's say I wanted to keep the graph exactly the same, but I wanted to move the midline up to 1. We want to say what transformation could make that happen. And the correct answer, that's a shift up, right? So that's a vertical shift. And down would do the same thing. So that is the type of transformation. So if I do an f of x plus or minus, depending if it's up or down, n. Which group of transformations would affect the amplitude? So now I want to leave the midline alone, and I just want to make the graph like taller here, so we can see that that's a vertical stretch. So if I have a function and I put a number in front of it, right, or a compression, right, would also do it right now to make it shorter, that will affect the midline, or the amplitude. If I want to affect the period, so let's say I want this graph to go faster, and I want it to be done by pi, not by 2 pi. So if I want to go like this, you can see basically I horizontally compressed it, and I could also stretch it if I want to make the period longer. And you can see when I drew these last 2 graphs that a horizontal stretch or compression is a completely different thing than a vertical stretch or compression on a sine or cosine graph. And that's why we spent so long on those in that first lesson. So to change the period, we want to do a horizontal stretch or compression. I'm spelling this wrong. Or compression, and that is changing where the x is. Okay, so we're going to start to look at these transformations and how we can read equations and find what changes have happened to graphs.